real privilege and a treat to be here with you. I thank you for the invitation. I think the first thing that all of us think about when we hear the word biodiversity is we think whales and pandas. But there's something that whales and pandas share with wheat and potatoes, aside from probably 50% of their genes. They share a need for diversity. Because if there's one constant in the world, it's change. And the one rule is you adapt or you die. And so what really governs and determines the fate of biological diversity is the diversity within species that allows not just pandas and polar bears and whales to evolve, but also wheat and potatoes and corn. Let's, yeah, we've already started, good. This is a familiar kind of diversity for those of us who work in agriculture. Diversity within the crop of beans. I'm just going to run very quickly and show you a number of other slides of diversity, but let me stop on this one for a second, and even though it's not rice. Let me say that very often when I'm talking with people about diversity in agriculture, I ask them, well, how many varieties of rice do you think there are? Now, if they know the kind of work that I do, they think a trick is involved, so they're quickly thinking, well, let me think. There's brown, there's white, there's Uncle Ben's. There's basmati, and there must be a few more, and I'm going to double my guess before I tell Cary. So they double it, and they say 15. Maybe sometimes they say 20. There are, in fact, about 120,000 different varieties of rice. Now, to put that in perspective, there are about 400 breeds of dogs. But with rice, 120,000 different varieties, each is different from the other, potentially, as a beagle from a Great Dane. This is the diversity that has evolved over the 15,000 year history of agriculture. It's the biological foundation of agriculture, and in fact, the biological foundation of our own life on Earth. Now let's look at a couple more pictures. You thought you knew beans, but actually you didn't know beans about carrots. This is an interesting plant. A few of you might recognize it. It's corn. It's what's called potted corn, and each one of the kernels has a little leaf over it. It's associated with a tribe in South America that brought it up all the way to Canada, and a god in quotation marks named Kokopele, who was supposed to be the god of fertility and the seducer of young girls, who was spreading this as a medicinal plant in ancient times. Squash is familiar to you. Here's an interesting slide of sorghum. The picture's not that great, but one of the interesting things about it is you see on the far left and also almost on the far right a crookneck sorghum. Some of these varieties of sorghum were developed in the Sahel in Africa by particularly clever farmers who were tired of having the sorghum mature and dry in the field and watch the birds eat it. So they developed a crookneck where they could string a rope inside their house and hang it up like a coat hanger to dry. And what this shows very starkly is that agricultural plants have actually co-evolved with human beings over the last 10,000, 12,000 years. This is one of my favorite photographs. I took it. This shows a woman I spent an afternoon with earlier this year in Ethiopia. The point of this picture is twofold. One is that you can't see all of diversity. Much of the diversity is hidden diversity because it's diversity that has to do with resistance to pests and diseases or drought or things like that. This woman is a farmer of lathyrus or grass pea. And one of the interesting things about this particular crop, it's a legume, so it fixes nitrogen, doesn't need fertilizer. It grows in some of the poorest soils in the world. It's perhaps one of, certainly the most drought-tolerant crops in the world. It's going to be a great crop for climate change. It's an interesting crop for the poorest of the poor in Africa now, but there's a problem with it. The good part is that when every other crop dies, Lathyrus continues to live. So if you're very poor and you're in a drought situation, which occurs in Ethiopia, India, Bangladesh, Pakistan, where grass pea or Lathyrus is grown, if it's a drought situation and everything else has died, you've still got something to eat, so it saves your life. The downside is that it has a neurotoxin. And so if you eat enough to survive, you also eat enough to paralyze yourself from the knees down forever. This is quite a choice. Obviously, you're not going to see it in the supermarket anytime soon, but it is rather tasty. It's like a sugar snap pea, and I've had it. It's very good. But it points to the fact that we need diversity because there are low-toxin varieties of Lathyrus in the Lathyrus collections that scientists have. And it points out why it's so important that we conserve all the diversity so that we can begin to breed varieties of crops such as Lathyrus for poor people and indeed for ourselves. Now, a lot of the diversity has already been collected and it's stored in seed banks, and seed banks is just a fancy name for freezers. Much of it is in bottles like this, but more and more we're turning towards these types of bags that seeds are stored in. We think that there are about 1.5 million distinct varieties of agricultural crops out there. So the goal of the Global Crop Diversity Trust is quite simply to conserve forever about 1.5 million distinct varieties of our agricultural crops. Now, it used to be that the main challenge that diversity had to meet was, well, we had to create crops that were disease and pest resistant and drought tolerant and yielded more and were more nutritious and were good for the farmer and good for the consumer. That was, of course, a simple task. But now things are getting more complicated because we have climate change, we have water shortages. Agriculture takes 70% of fresh water supplies, and of course there's competition with cities for that. And there are looming energy shortages. So now agriculture is going to be asked to do many, many more things. Here's a slide taken from Greenland, and the interesting thing about this slide is this is a church. This is a church where the last wedding ceremony was performed of the Norse settlements in Greenland in 1408. The settlements died out. The Norse died out in Greenland. They died out because they didn't adjust to climate change. They wanted to continue to farm like Europeans, but the climate was changing and they couldn't do it. This is a future that we have in front of us if we're not able or not willing to adjust to climate change ourselves. We recently co-sponsored a small seminar with Stanford University and Rockefeller Foundation looking at the climate of the last 100 years versus the climate of 2070 to 2100. And the next couple of slides are, to me, very powerful because what they show you is the average temperature in a growing season in the different countries for the last 100 years, for 2070 to 2100. And what you see, if you look at the top one, Bangladesh, is that the warmest or hottest 5% of the growing seasons of the last 100 years, being about 28 degrees centigrade, will in the future be the coldest. In fact, they'll even be colder than the coldest because there's no overlap at all in these two bell-shaped curves. I'm not playing with the data. This is true just country after country. This is an unprecedented situation, and frankly, I don't know if we're ready to cope with it. I don't think agriculture is at the moment. What it means is that we're headed very quickly towards a situation that our agricultural crops have never seen before. A globally and locally warmer temperature than has been experienced since the beginning of the Neolithic time. Just another shot. If we're going to cope with this, we've got two choices, right? We can either modify the environment to suit the needs of the crops, but hey, haven't we already tried that one? or we can modify the crops to suit the environment. And if we're going to modify the crops to suit the environment, then of course we're going to need the diversity to do that. So the question then for us is, at the Global Crop Diversity Trust, is what are we going to do about it? Well, in a nutshell, I'll tell you very quickly. We have identified the most vulnerable and most unique collections of agricultural crops around the world. We believe that about 50% in terms of numbers are endangered. So in the next 4 years, we're going to rescue, literally rescue, from the brink of extinction, about 165,000 different crop varieties. We're going to make sure that they're safety duplicated in a good seed bank, and we're going to make sure that they're safety duplicated in an ultimate fail-safe facility that I'll show you just in a second. We're going to construct information systems so that researchers and plant breeders can access this material. We're going to evaluate that material for traits, particularly associated with the poor and with climate change. And we're going to research crops that are difficult to conserve and develop better ways of conserving them. In a sense, what we're going to do is we're going to, for the first time, create a global system for caring for the most precious natural resource on Earth, at least the most precious one for human life. We're going to sustain that system by creating an endowment fund that will throw off enough income so that we can conserve this diversity in perpetuity. We've made a good start. We're not quite there. Now, of course, every good system, every good plan needs a backup plan, a plan B. And I'm in love with our plan B. Our plan B, as Andrew mentioned, involves Svalbard. And let me see if I can get this pointer to work. For those of you who don't know Svalbard, it's there. It's as far north as you can fly on a regularly scheduled airplane. If you start off in northern Africa and you fly to Oslo, Norway, you're halfway there. What we're going to do in Norway is build a safety backup for seed banks, because we're losing diversity. We're losing it every day. We're losing it on the farms as farmers replace old varieties with modern varieties, and we're losing it in seed banks. 2 seed banks that were recently destroyed were in Iraq and Afghanistan. You can guess why. But a typhoon hit the Philippines gene bank about a year ago and halfway destroyed that. And we have mismanagement and equipment failures and all kinds of things that end up meaning that we destroy diversity. And when we destroy diversity, or when we lose diversity, this is not an antiseptic process. This is extinction. That means that we're losing traits and we're losing options for the future that we will never have again. And in the light of climate change and energy shortages and water crises and such, this is not the time to start throwing away options. So I want to show you a couple of slides very quickly of the area just around where we're building the Svalbard Global Seed Vault. I took these photographs on Monday and Tuesday of this week, so it'll give you a sense of what it really looks like right now. This is a big glacier in the area. You would be quite tiny if you were standing beside this. Yes, it is melting, but we think that still Svalbard and this area of the Arctic will remain at least relatively colder than most places. And if you want to conserve seeds for a long time, I should have said, you freeze them. The technology is pretty straightforward. You freeze them. So here we've tried to devise a system where we can conserve this diversity with as little sort of interference and possibility of things going wrong as possible. It's appropriate technology. We're going to use nature. Here's another shot of that glacier, and you can kind of see how it's going to calve off a little bit. But it's still gigantic and still, I promise you, very cold. This is a little town of Longyearbyen. It's a Norwegian town. Wonderful infrastructure, great people. The seed vault that we're building is just outside of this town. The Norwegian government is funding the construction of this seed vault. It'll cost about $8 million. We are assembling the seeds from around the world, and our endowment fund will pay for the upkeep of this facility forever. We anticipate that those upkeep costs, just in case you want to know, will be about $125,000 a year. So we don't need a gigantic endowment to do that. We think it's the world's cheapest insurance policy for the most valuable natural resource that we have. Here's a drawing. You can see the outside. We call this a portal building. It's going to have a really nice light. And then when you open the front door, if you have that chance, you're going to walk into a tunnel that will lead you back inside of a mountain carved out of solid stone. It's going about 125 yards into the mountain. And there'll be a few security doors along the way. And then you'll see 3 vault rooms where the seeds will be stored. This is not pie in the sky. This is actually being constructed. So in the sort of lower right-hand portion of this, you can see an aerial view of that outer portal building that I showed you on the diagram just a second ago. It's under construction, and well, you'll see the rest of it in just a second. Here's another view of it. You can get a sense of scale there. Now we'll get down on the land. It's always going to be up a little bit in the front. They've designed it so that the wind will blow underneath it and wash the snow away. There are polar bears in this area, and 2 or 3 have visited while the vault has been under construction. This is sort of at the end of the tunnel, actually looking towards the entrance, but gives you a sense of how big it is. The tunnel itself was made with machinery that you would make for building a tunnel through the mountain for cars and automobiles, for trucks and things like that. Here's another, the diagram again, and I just want to point out that the next shot I'm going to show you, it's sort of cool, is from this area. It's at the end of the long tunnel where it hits that T section there. And that's this. I hope you can make out from out there that this is a sort of a concave structure, kind of shell-shaped. And I wouldn't say that we've thought of everything, and I certainly wouldn't say that nothing can go wrong. But God forbid if someone were to have an explosion at the front of this seed vault or fire a rocket inside or whatever, it would hit this part, which is solid stone going all the way through the mountain. And that structure, shaped as it is, will channel the force wave back out the tunnel instead of into the seed vaults themselves. Here's one of the 3 seed vaults. We can store about 1.5 million samples in each one, and that's about as many as we think exist. We have a capacity for storing 3 times that. That means that we could have been wrong. Well, in summary, let me say that we really do believe this is the most valuable natural resource on Earth. We think it's the common heritage of mankind, and that we have a common responsibility for what is the common heritage. Very often I ask people, can you think of an effective, efficient, and sustainable solution to climate change, to energy shortages, to water shortages, to food security, that does not involve crop diversity, that doesn't involve agriculture playing a main role? I can't think of any. So the problem of losing this diversity is, in fact, a problem of global significance. It is one of the greatest global problems that we face. But unique, I think, unique among all of those problems, this is one we can actually solve. We can solve it pretty quickly. We can end the mass extinction of crop diversity that's taking place, and we can ensure that all of that common heritage will be around for many generations to come. We have the people. We have the institutions. The technology is not pie in the sky or futuristic. It's very simple. You've got it in your kitchen. It's called a freezer. We're now trying to assemble of course, an endowment fund, not just to fund the global seed vault that I've shown you, but to fund a network of seed banks around the world and to make sure that biological diversity can be conserved forever. In other words, we believe that we can solve this problem crop by crop, once and for all, and that by solving it, we can contribute quite dramatically to solving most of the other problems in the world. Thank you.